and gentlemen, today you're going to use this video lesson to help understand lesson 3.3, writing linear equations from key information. So the first thing I want you to do is I want you to pause this video and answer these two warm-up questions in your notebook. Like always, you should have the title at the top of the page, and then you have two warm-up questions to answer. You're going to write the equation of the line for each graph shown. We're practicing the skills that we learned yesterday, so please pause the video now and answer these two warm-up questions. Now that you've had a chance to answer the warm-up questions, let's go over them. For the first one, you should have found the equation of the line is y equals 1/4 x plus 3. Remember, we can take that y-intercept, we see where we cross the y-axis, and then we find our slope. And to find our slope, we can use a slope triangle, or we can use the slope formula. If I'm using a slope triangle, I know that I change up 1y for every 4 spaces. I change positive x, or I can do y2 minus y1 over x2 minus x1. Either way, we get to our final answer here. For our second graph, we should find that the equation looks like y equals negative 2x, or negative 2x plus 0. The y-intercept is 0 because I go through that 0 point. And then I can choose my 2 points and build a slope triangle, or I can use the slope formula. So moving on, today we would correct lesson 3.2, but because I am not here, we're going to continue on. Save this assignment. We will grade it when I return. You'll see that it's out of 19 points, so make sure that it's done before we correct this assignment. Our job today is to learn how to write linear equations from key information. So that target there, we're going to write a linear equation in slope-intercept form when given information about the line. So in your notes, you have a few steps that you're going to write down. First thing we need to do is we need to find the slope of the line. Sometimes the slope of the line will be given to us. It'll say the slope is 3/2, or the slope is -4. Sometimes we might need to use a slope triangle if we're looking at it on a graph. Or we might need to use the slope formula if we're looking at two ordered pairs. This next step is where it gets a little bit trickier. I want to find the y-intercept of the line. Sometimes it'll be straightforward. I can identify it on the graph where it crosses the y-axis. But sometimes it's necessary to substitute the slope m and one ordered pair, xy, for the corresponding variables in the equation, y equals mx plus b, and solve for b. This sounds kind of confusing right now. Please copy down this entire step, and then we will practice what this looks like. Once we have our two pieces, once we have our slope and our y-intercept, all we need to do is plug them back into the equation in the form y equals mx plus b. So let's practice with this. In example number 1, I want to write the equation of the line that has a slope of 1/2 and a y-intercept of 3. So I know from the steps that I just wrote down, my first goal is to find the slope. Well, slope of 1/2, so I know that my slope is 1/2. And I have a y-intercept of 3. Well, my second step is to find the y-intercept. My b value is -3. In this case, I was given both pieces of information that I need, so I can jump to writing my equation. Y equals mx plus b. I can write my equation as y equals 1/2 x minus 3, or y equals 1/2 x plus a -3. Both options are correct here. They are mathematically equivalent. Well, let's make it a little more challenging now. This one here, I want to write the equation of a line that has the slope of -2/3 and goes through the point 3, -5. So again, my step 1, I need to find the slope, and in this case here, I found it. My slope is -2/3. But to find my y-intercept, this is that step 2, where if necessary, substitute in the slope and 1 point into the equation to solve for b. What I see is I have m, and I have an x and a y. So I'm going to use my equation, y equals mx plus b. And I'm going to plug in the pieces that I know so that I can solve for the missing piece. I have a y value of -5 from my ordered pair here. My m value, my slope, is -2/3. My x value is 3. And my b value is unknown. That's the unknown piece. But now in my equation, I only have one unknown piece, so I can use my order of operations and my equation solving skills to isolate my unknown. I need to multiply negative 2/3 times 3. Well, using all my fraction multiplication rules, I know that this turns into negative 5 equals negative 2 plus b. Negative 2/3 times 3 is negative 2. To get rid of negative 2, I add 2 to both sides, and I find out that b is equal to negative 3. Now that I have my two pieces, I can write the final equation of the line, where I go back to this original y equals mx plus b, and I have y equals m, my slope of negative 2/3, times x plus my b value, or in this case, minus 3. Minus 3 or plus a negative 3. Those are mathematically equivalent. One more problem here. This time I have just two ordered pairs. I want to write the equation of the line that passes through the points 2, 7 and 5, negative 2. So step 1 tells me I need to find my slope of my line. In this case here, I have two ordered pairs, so the best choice would be to use the slope formula. I could get out graph paper, plot my points, connect the dots, and draw in a slope triangle, but I know that that's really getting me to the same goal as using the slope formula. So if I label my parts here, I have x1, y1, x2, y2, and I can plug that into my slope formula. y2 minus y1 over x2 minus x1. Well, negative 2 minus 7 gives me negative 9. 5 minus 2 gives me 3. If I simplify my fraction, negative 9 over 3 is negative 3, which tells me my slope is negative 3. Now I have to use my slope and one point to find my b value. It doesn't matter which point I choose. I should get the same answer either way. So I'm going to choose that first point because I think using positive values is easier. I'm going to start again with y equals mx plus b, and I'm going to plug in what I know. I have a y value of 7. My m value is negative 3. My x value is 2. And my b value is unknown. So using my equation solving skills, I find out that 7 equals negative 6 plus b. Add 6 to both sides, and I find out that b is equal to 13. If I take my pieces and put it back into my equation, I have y equals my m value of negative 3 times x plus my b value. I found the equation of the line with the two ordered pairs. Ooh, another practice here. This time I want to write the equation of the line that passes through the point negative 6, negative 2, and has a y-intercept of 1. Well, typically I would find my slope first, but in this case here, there's two different ways I can do it. One way is I can take that y-intercept and I can turn it into an ordered pair. I know that if my y-intercept is 1, I can write that ordered pair as 0, 1. From there, I can find the slope of my line using the slope formula. But the other thing I can do, and I think an interesting way to approach this kind of problem, is to think about it like a puzzle. In my puzzle here, I'm given an x value, a y value, and my b value. That b value is 1. So I can go to my equation, y equals mx plus b, and plug in what I know. My y value is negative 2. My m value is unknown, so I'm going to leave it as a variable. My x value is negative 6, and my b value is 1. Now when I use my equation solving skills, I need to isolate m. I need to get the slope by itself. So the first thing I'll do is I'll take away 1 from both sides, and I get negative 3 equals m times negative 6. The other way of writing that, it would be negative 6m. Typically, we list the coefficient first and the variable second, but with multiplication, order doesn't matter. Final step is to divide by that negative 6. I want to get m by itself. Negative 3 divided by negative 6 is equivalent to positive 1/2. So my slope is 1/2. Now that I have my pieces, I can plug it into my final equation. Y equals my slope of 1/2 times x plus my b value of 1. This one's kind of tricky here. If this idea of solving for the missing piece was throwing you off, go back, turn the y-intercept into an ordered pair, and then solve it like we did example number 3, where you find the slope of the line between the 2 points and then find the b value. Now that we've practiced each of those question types, let's dive into this explore activity. So please get out your worksheet now that says Lesson 3.3, Explore. We're going to deal with these triangle lines. A triangle consists of 3 line segments. A segment is a portion of a line. So the first thing I want to do is I want to find the equation of the line that contains the line segment AB. Well, to do that, I'm going to use the skills that I worked on in 3.2, where I can identify the slope and intercept using what I know from the graph. So if I look at this graph here, I can see my y-intercept. I cross the y-axis at y equals 6, so my b value, my y-intercept, is 6. To find the slope, I want to build a slope triangle, a messy slope triangle here. I see that my change in y, I go from a positive 5 to a positive 8, so my change in y is a positive 3. My change in x, I go from negative 2 to positive 4, so my change in x is 6. So my slope is equal to my change in y over my change in x. And if I simplify that fraction, 3 over 6 simplifies to 1/2. The equation of my line then looks like y equals 1/2 x plus 6. Now I want to find the equation of the line that contains AC. So just like before, I'm going to identify where I cross the y-axis, and I see that I cross the y-axis at a value of positive 4. So my y-intercept is positive 4. To find my slope, again, I'm going to draw in a slope triangle, and you can draw it in on your graph there. My change in y, I go from a positive 5 to a positive 2. So that's a change of negative 3 for y. My change in x, I go from negative 2 to positive 4 again. So I have a change of 6. So this time, my slope is negative 3 over 6. When I simplify, I get a slope of negative 1/2. So the equation of my line looks like y equals negative 1/2 x plus 4. The last one for line BC, I don't cross the y-axis. If I look at this here, I have a vertical line. At this point in my mathematical career, I should recognize that that vertical line has an undefined slope. So there's no y-intercept. I'm going to put NA for not applicable. My slope is undefined, so I can put undef. But I can write the equation of this line. Let's switch to another color. Yellow is kind of hard to see. The equation of this line is going to look like x equals a constant. X equals a number. If I look at this line here, I see that no matter what value I have for y, my x value is 4. So the equation of the line looks like x equals 4. Those 3 lines are built, or those 3 line segments are built from the 3 lines given. Remember our definitions here. A line extends to infinity in both directions. A line segment has ends. It has points where it starts and where it stops. Well, now Ryan made his own triangle. He chose 3 points and wants you to find the equation of the 3 lines that make up his triangle. His points are Q, 3, 3, R, -2, -7, and S, -7, -2. Find the 3 linear equations that intersect to make his triangle. So we don't want to graph these. We want to see if we can figure out the equation of the lines without graphing. So the first thing I want to do is I want to find QR. So the first thing we need to do here is we need to find the line QR. We need to find the slope between Q and R. So I want to list out those points again. Q is 3, 3, and R is -2, -7. So I'm just going to rewrite that. And you should follow along on your sheet here. So Q is 3, 3. R is -2, -7. And I know that I'm using my slope formula, so I want to label my pieces x1, y1, x2, y2. For my slope formula, I take y2 minus y1 over x2 minus x1. And I find that -7 minus 3 is -10 over, well, -2 minus 3 is -5. When I simplify my fraction, I find a slope of +2. Now that I have my slope, I need to find the y-intercept. So I'm going to take my slope and one point, and in this case, I'm going to use q because it has positive values. And I'm going to go back to y equals mx plus b and plug in what I know. So I have y equals m times x plus b. Well, I know that I need to multiply 2 times 3, and I get 6. So I get 3 equals 6 plus b. When I take away 6 from both sides, I find out that my b value is -3. Put the pieces together. The equation of the line for QR looks like y equals 2x minus 3, or y equals 2x plus a -3. Well, now I want to find the line between R and S. So I'm going to start with R, -2, -7, and S, -7, -2. And again, I'm going to label my pieces, x1, y1, x2, y2. And I'm going to use that slope formula, -2 minus a -7 over a -7 minus a -2. Well, -2 minus -7 is the same as -2 plus 7, so I get 5. -7 minus a -2 is the same thing as -7 plus 2, so I get -5. When I simplify 5 over -5, I find out that my slope is equal to -1. Now I'm going to go back and I'm going to take my slope and one point, and it doesn't matter which point. I'm going to use S this time, just as right there. I have my y value equals my m value times my x value plus b. Remember, each time when I'm solving these ones here, I'm going back to that idea of y equals mx plus b. -2 stays the same. Well, -1 times a -7 is a +7. +7 plus b. Well, to get b by itself, I have to take away 7 from both sides, and I find out that b is equal to -9. If I put my pieces back in the correct spot, my equation looks like y equals -1x minus 9. So I found the equation of the line for QR. The equation of the line for RS, this was QR, RS, and now I need to find the equation of the line for QS. Again, I'm going to start with my points. I have Q, 3, 3. S, -7, -2. My pieces, x1, y1, x2, y2. When I plug them into the slope formula, I get -2 minus 3 over -7 minus 3. -2 minus 3 is -5. -7 minus 3 is -10. When I simplify my fraction here, negative over negative is positive. 5 over 10 is 1/2. So I find out that my slope is equal to 1/2. I'm going to take one of my ordered pairs. This time I'm going to go back to using Q because it's positive. And I want to plug in my y value equals my slope times my x value plus b. Well, that gives me 3. 1/2 of 3 is 1.5. To get b by itself, I subtract 1.5. And I find out that b equals 1.5. If I put the pieces back in the correct spots, I get y equals 1/2 x plus 1.5. So I have the equation of my 3 lines here. Now in step 5, I want to graph those lines. The points where the line segments meet in a triangle are called vertices. Graph your 3 lines using the slope and y-intercepts from your equation. Does the triangle that is formed have the same 3 vertices that Ryan chose? So if I look at this here, I just rewrote my equations of my lines. Y equals 2 minus 3x, y equals 2x minus 3, y equals negative 1x minus 9, and y equals 1/2 x plus 1.5. When I graph my lines here, well, I start for that first one that I have in green, I want to start at negative 3, and I go up 2 over 1, up 2 over 1. I get 3 points, then I connect the dots and I extend. I should get a line that looks like this. For RS, I start at negative 9, and I go down 1 to the right 1. I ran out of space on my graph, so now I'm going to go up 1 and backwards. I'm going to go negative x1. So I get that same line. I have my 3 dots. I connect and extend across the screen. For the last one, I start at a y-intercept of 1.5, so halfway between 1 and 2. I go up 1 and to the right 2 each time. I get 3 dots, connect and extend, and I see my graph here. If I check my vertices, the places where those lines cross, I should see that Q is at 3, 3, where the red and the green lines cross each other. R, negative 2, negative 7, well, that's where the green and the purple line cross each other. And S is where that red and purple cross each other. So you should find out that, yes, your triangle has the same vertices as the one that Ryan chose. Now for the rest of time today, I would like you to work on worksheet 3.3. We just walked through that Explore activity together, so you should have finished it. But if you flip it over, you'll see that there are 12 more practice problems here, where you need to take the given information and write the equation of the line. You'll have class time today, and you'll have the entire class period tomorrow to finish this assignment. It needs to be done by the time you walk in the door on Monday. Thanks, ladies and gentlemen.